Welcome to the next unit of the acids and bases topic. Today we're going to look at the properties of these acids and bases. So by the end of the unit you should know that most acids have observable chemical characteristics and chemical reactions, which we'll highlight, that the salt and water are produced in exothermic neutralization reactions, which you probably should know from last year. And by the end of the unit you should be able to balance these equations of these reactions and identify the acid and base needed to make different salts. And also you should have some experience of acid base titrations with different indicators. So in terms of the properties of acids, they often produce protons in water. We can also write them as the hydronium ion, which is the hydrogen ion attached to a water molecule. Okay, so basically you have the proton in the water, then the water molecule comes along, and this is of course in an equilibrium to give the hydronium ion. Okay, that's what it's basically saying. They taste sour, of course, from the ancient Greeks. They corrode metals. They are electrolytes because they're charged species. They react with bases, particularly metal hydroxides, to form a salt and a water. They react with carbonates to form salt, water, and carbon dioxide. They react with metals, metal oxides, to form salt and hydrogen gas, which of course can be tested by the squeaky pop test, where of course you put a splint in and it goes pop and extinguishes the flame. The pH is less than 7, and we'll look at pH further in other units, and it turns blue litmus paper red, phenolphthalein colorless, and methyl orange red. Okay, so the key chemical reactions are acid plus base gives salt plus water, given of course the base is a metal hydroxide or a metal oxide, and usually it's an alkali, the metal hydroxide. And the example there is hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. The second kind of reaction, of course, is the reaction of a metal with acid to give a salt plus hydrogen, which of course you can test through the lighted splint squeaky pop test. For example, hydrochloric acid plus magnesium giving magnesium chloride, a salt plus hydrogen. Note, of course, that equation is obviously not balanced because you've got two chlorides on the reactant side, on the product side, and only one chloride on the reactant side. Acid plus metal carbonate gives salt plus water plus carbon dioxide, and there's an equation there, of course, again, and again it's unbalanced because again you've got two sodiums on the reactant side and only one on the product side. In terms of testing for carbon dioxide, that's of course the lime water test, which goes cloudy when it bubbles carbon dioxide gas through. So in terms of naming acids, and you have been familiar with them now from last year as well. So if it's two elements, then you have a hydro prefix and a ic at the suffix. Okay, so for example, hydrogen and chlorine, hydrochloric acid. If it's more than two elements, so 3 elements, then there is no hydro prefix, and there is an ate ending becomes an ic ending, and an ite ending becomes a ois ending. So the case in point there would be, as an example, sulfuric acid, okay, because it contains hydrogen, sulfur, and oxygen, so there's no hydro prefix, and the sulfate becomes a sulfuric ending. And if it was SO3 instead of SO4, then it would become from sulfite to become sulfurous, so hydrosulfurous acid. It's the same with organic molecules in that sense as well, so something like ethanoic acid containing 3 different elements, so again no hydro prefix, and you have the ic ending. Okay, so a quick learning check of that. So here are 3 different acids. Now try and name them. Okay, so the first one, it's 2 atoms, so it must be hydrobromic acid. Okay, the ic ending as well. There's 3 elements in the second one. It's going to be carbonic acid. Okay, the hydro's been dropped. We've got 3 elements in there. And here it's come from the sulfite, so it must be sulfurous acid. So just to finish off, the properties of bases. They are often producing hydroxide ions in water, don't always, but generally they do. Okay, so they're alkalis. They taste bitter as opposed to sour for acids. They are also electrolytes with this charged species, the hydroxide ion. They feel soapy or slippery on the skin. They react with acids to form salt and water. This time the pH is greater than 7. And they turn red litmus paper blue, phenolphthalein pink, methyl orange yellow. And an alkali is a base that is soluble in water. Okay, so that's pretty much all we need to know for this unit. Next unit, we're going to look at the pH scale. So what does that mean when we say a pH of 7?